I'm Lca Epd, Associate Marketing Manager at Armstrong World Industries in Lancaster, Pennsylvania. Thank you for joining me today. Let's get started. The title of this CEU is Lifecycle Assessment and Environmental Product Declarations, the next level of transparency. Let's go through the course learning objectives. At the end of this course, participants will be able to understand the need to reduce the impact of buildings on the environment, introduce life cycle assessment, or LCA for short, evaluate how LCA can be used as a tool for product selection in the building industry, also interpret environmental labels, understand, read, and interpret an environmental product declaration, or an EPD for short, define the role of an EPD program operator, explain how EPDs are currently being used and applied, and then describe the differences between LCA and an EPD. You'll learn to apply these tools to formulating product specification choices and learn to appreciate the value that these tools bring to the building industry. As the world's consumption of natural resources continues to grow at an increasing rate, the design and manufacture of environmentally responsible products for use in the built environment is no longer a nice-to-have, but a necessity. From cell phones to clothing, food crops to building products, producers are giving increased attention to the environmental impact of their goods across the entire product life cycle. Buildings are complex. They provide shelter, act as communication and data terminals, as well as centers of education, justice, and community. They are incredibly expensive to build and difficult to maintain effectively over their life cycle. The economics of the built environment have become as complex as building design itself. Data from the US EPA illustrates that in the USA, buildings account for 39% of total energy use, 68% of total electricity consumption, 12% of total water consumption, and 38% of total carbon dioxide emissions. Americans spend 90% of their time indoors, and indoor levels of pollutants are 2 to 5% higher than outdoor levels. The built environment has a vast impact on the natural environment, human health, and the economy. By adopting green building strategies, there is a potential to maximize both economic and environmental performance on projects. Green construction methods can be integrated into architecture at any stage, from design, construction, operation, and deconstruction. However, the most significant benefits can be obtained if the design and construction team integrate green strategies at the earliest stages of a building project. As the building industry increasingly emphasizes sustainability and transparency, several labeling methods have been developed to evaluate and reduce environmental impact of products used on projects. Despite this, the effort to understand companies' sustainability claims is still a problem that exists worldwide. How does someone purchasing or specifying a product become educated on what its environmental impacts are? How should companies manufacturing the products communicate their environmental claims to the public? These questions have resulted in a myriad of answers, from outright greenwashing by companies to manufacturers' unverified claims to certified labels. There has been a big focus on individual attributes of a product's environmental performance, things like recycled content, rapidly renewable content, or location of manufacture and extraction, many of which have been driven by codes and rating systems. But these ways of measuring a product's environmental impact may not tell the whole story. So, what is the solution? LCA, or Life Cycle Assessment. It's a tool that allows building professionals to understand the environmental impacts associated with the products they select to use on their projects over the entire life cycle of the product. Scorecard approaches like the LEED rating system provide a specific list of do's and don'ts to be applied during the design process. The credits earned by projects designed under LEED do not provide feedback on how well a product selection could perform environmentally or otherwise after occupancy. LCA, on the other hand, is a look at the product's environmental impacts at all stages of a product's life and aids in architectural decision-making to help you understand the environmental impact of product specification choices long-term. LCA will likely replace the attribute-driven selection criteria that was prevalent over the last several years in environmental rating systems like LEED. Simply put, life cycle assessment, or LCA, is a tool to measure the environmental impacts associated with each stage of a product's life cycle. First, there is the birth of a product idea in design. Once a product moves from idea to reality, raw materials become inputs into the production of the product. And the product is manufactured. Once a product is ready to go, the finished product is packed up and transported to a retail store or a distributor's warehouse. There it is purchased by the installer. After this, the product is installed and used by the occupants in the building for a certain span of time. Eventually, a product's usable life will come to an end, and a decision will have to be made on disposal method. Perhaps it can be recycled, or perhaps it will end up in a landfill. When a company commits to completing an LCA for their product line, they are left with a plethora of information about the environmental impacts at every stage of a product's life cycle. This information could literally fill volumes. So what is a company to do when they want a clear, concise way to communicate LCA information to the public? Well, they usually put a label on it. How do you tell one eco-label from the next? How much does your firm rely on these labels when making specification decisions? Which of these labels do you consider important or useful? Let's take a few moments to put different types of eco-labels into perspective. Type 1 eco-labels verify compliance with a specific environmental standard or attribute. For instance, USDA bio-based certification. Type 2 eco-labels are self-declarations often used by manufacturers to claim an environmental benefit related to their product or its use. An example is General Motors' Ecologic label. Lastly, there are Type 3 ISO certified eco-labels. These are succinct, third-party verified, fact-based documents that provide specific information by category. The most popular format for a Type 3 label is an Environmental Product Declaration, or EPD. A Type 3 label summarizes a product's life cycle assessment results. Before we move on, it's important to understand the difference between LCC, or life cycle cost, and LCA, the topic of this seminar, life cycle assessment. Life cycle cost is the process of economic analysis to assess the total cost of ownership of a product over its lifetime, including the cost of installation, operation, maintenance, and disposal. Life cycle assessment is instead an analysis of the environmental impacts of a product over its lifetime in categories including global warming potential, primary energy usage, and water consumption. International Standard Organization, or ISO, standards 14025, 14040, and 14044 detail how a life cycle assessment should be calculated. There are 4 key stages to a life cycle assessment. 1. The goal, scope, and definition. In this stage, decisions are made about what should be studied and how the results of the study will be used. 2. The life cycle inventory, or LCI. In this stage, the data is collected, modeled, and analyzed. 3. Impact assessment. This stage encompasses the analysis of the ultimate effects of the life cycle inventory results. 4. Interpretation. This is where the data is published and made available to the public, usually in the form of an EPD or Environmental Product Declaration. Companies who perform life cycle assessments on their products apply the results to these part of their businesses: product development and improvement, strategic planning, and public policy making. The LCA methodology operates at one of four levels. The industry level. At the building industry level, an LCA quantifies the impacts of suburban sprawl and urban densification and changes in land use. LCA at this industry-wide scale is not typically actionable by a practicing architect. Rather, it is LCA at the smaller scales, material, product, and building, that the architect can contribute. The building level. Whole building LCA is a life cycle assessment where the building is the product. In this case, the architect can be the LCA expert, as the architect understands how the building is constructed, how building materials and products flow to the job site, and how the building is going to be operated over time. The product level. At the product level, an LCA is calculated as a collection of raw materials which are assembled into a final product. A composition view of the product is completed, and the emissions from each ingredient of the product are tallied. To complete a product LCA, a thorough knowledge of the source and quantities of raw materials, as well as intimate knowledge of the supply chain and manufacturing processes of the finished product are required. Product-level LCA data is useful to architects as it can assist them in making informed finish selections for their projects. The material level. At its core, LCA is defined at the material level. It is not likely that an architect or any building industry consultant would be called on to produce material-level life cycle inventory data. This information is calculated by process chemists, chemical engineers, and submitted for inclusion in various LCI databases that companies producing product LCA data use as a resource. A life cycle assessment looks at various areas that affect the environment called impact categories. As an LCA for a product is evaluated by a design professional, it is important to keep in mind which of these categories are most important to the project, your client, or your firm. Typically, the two most important categories to the commercial building industry are global warming potential and primary or embodied energy. Global warming potential is also known as the carbon footprint. This takes into consideration greenhouse gas emissions or other emissions that contribute to climate change. Primary or embodied energy is the amount of energy from both renewable resources like solar and non-renewable resources like fossil fuels used in the raw material procurement for a product and the amount of energy required to manufacture the raw material into a new product. Other common impact categories include ozone depletion. This happens when emissions cause thinning of the Earth's stratospheric ozone layer. This adversely affects human health, natural resources, and the environment. Acidification potential. These are air pollutants or emission that turn into acids and harm buildings, plants, animals, aquatic life, and human health through acid rain. Eutrophication potential. This is when materials contribute to the increased quantity of nutrients that leach into water or the soil and cause the natural biological balance to shift. Water consumption. This is the total amount of water required to produce a product. Smog or photochemical oxidant creation potential. This is when emissions of chemicals cause smog or air pollution. Life cycle assessment is beneficial to creating better products in the following ways. It can spur innovation while manufacturers are developing new processes or new products. When purchasing raw materials, the LCA process may aid in choosing raw materials with lower impacts. Also, LCA is a standardized way for a company to communicate transparency or to declare the environmental impact of their products. Let's look at typical ways LCA could be used during the design process. During the pre-design or programming phase, LCA can help define the environmental goals of a project. The basic decisions for choosing a structural system can be assessed, and the trade-offs between impacts from the construction phase and the operational phase can be evaluated when selecting different building assembly types. During schematic design, choices regarding selection of building products and assemblies can be made, while energy conservation measures can be assessed for their environmental burdens. In the design development phase, LCA can help evaluate the lifelong impacts of proposed lighting and HVAC systems. Also, material finishes can be compared with the help of LCA results, and the proper choices can be made for the project. So, how is life cycle assessment information best communicated? Well, first we'll need to understand the distinction between a life cycle assessment and an environmental product declaration. An EPD is easier to read than a complete LCA, and it's a declaration of the LCA results for a product. An LCA is a very broad collection of documents which could be very difficult for the average person to interpret. There also may be many variances from LCA to LCA across an industry. EPDs simplify this information by consolidating it into a shorter document that outlines a product's environmental impacts. As mentioned earlier, the building industry is crowded with eco-labels and single attribute claims, and as a result, EPDs, or environmental product declarations, are emerging as the dominant Type 3 label used as a tool for seeing a product's life cycle impact in full disclosure. EPDs are most often linked to the concept of a nutrition label. An EPD addresses the needs of both manufacturers and buyers seeking clear, credible, and precise information about the environmental impacts of a product family. In the commercial building construction field, EPDs simplify the process of making informed, direct comparisons of similar products. Despite these trends, the purpose and usefulness of EPDs are not widely understood today. And by the end of this presentation, this will hopefully no longer be the case for you. So, what type of information is found in an EPD, or Environmental Product Declaration? Well, the main focus of an EPD is the summary of a product's LCA, including information on the product's performance in environmental impact categories like global warming potential and water usage. It may also contain performance characteristics of the product in question. An EPD discloses the ingredients and raw materials used to make a product, along with information on where the raw materials come from. Additionally, an EPD typically includes other environmental and health-related impacts that are of particular interest to the industry, which will utilize the EPD. Keep in mind, an EPD is a statement of fact. It does not judge whether a product meets any particular environmental quality standard. Instead, users are responsible for making judgments about how the information presented impacts their project. EPDs are based on product category rules. Product category rules, or PCRs, specifically define what information is to be reported in an environmental product declaration so that it can accurately reflect a product's environmental impact. Each industry or product type will fall into a specific product category rule. An open consultation procedure takes place around the draft of any new product category rule. Any interested party that has specific questions or wishes to comment on the document is allowed to participate. These parties may include material suppliers, manufacturers, trade associations, purchasers, users, public agencies, or certification bodies. This assures that the rule is applicable and useful to the industry for which the rule was created. There are 5 steps involved in the creation of an ISO-compliant environmental product declaration. First, select the appropriate product category rule. PCRs describe the scope and methodology for performing an LCA. They form the data foundation for an environmental product declaration and provide detailed requirements for additional environmental and health information disclosure. Second, the team must conduct and verify the product lifecycle assessment. Once a lifecycle assessment is conducted, it must be verified and checked to make sure it meets the requirements defined in the product category rules. Next, an EPD has to be compiled. Once the applicable product category rule has been identified and a life cycle assessment has been completed and verified, an environmental product declaration can be prepared. Next, the team must verify the EPD. When an environmental product declaration has been completed, it must be submitted to an independent third-party program operator for a thorough review and verification of the results presented. The last step in the process of creating an ISO-compliant environmental product declaration is the submission of the final document to an EPD program operator for registration and inclusion in the operator's published list of registered EPDs. There is no standard format for an EPD, but generally an EPD will contain the following information. There'll be a product description. This section might include photos of the finished product, a list of typical applications where it could be used, product specifications including performance features, and information about product raw material content. There should also be a section on manufacturing or production process. This will explain how a product is manufactured and also evaluate health, safety, and environmental impacts that are associated with the manufacture of the product. There will also be a summary of the product's life cycle assessment, and that's the focus of the EPD. It will describe the LCA modeling approach used, information on how the LCA was prepared, and a description of the functional unit used. This is the unit of comparison that allows products to be compared across an industry. An EPD may also include any other information that a manufacturer deems relevant. This might include information on installation, maintenance, or process to recycle product at the end of its useful life. EPDs have been used extensively for years, mostly in the European Union and in Japan. In France, the government-backed Environment Roundtable, Le Grenelle Environment, has proposed that all high-volume products imported into the country be accompanied by an EPD. The United Kingdom's Building Research Establishment Environmental Assessment methodology currently uses EPDs as a guidance tool to help licensed assessors select green building products. Outside of the EU, Masdar City, a large-scale eco-city project in Abu Dhabi, is encouraging the use of EPDs and LCA to evaluate the products used in its construction. As EPDs are already widely used in other industrialized nations, recent efforts by both government and industry in the United States confirm their popularity is growing here.